Hello everyone, I'm Yingchaojie Feng from Zhejiang University. Today I will present our paper, PromptMagician, Interactive Prompt Engineering for Text-to-Image Creation. With the fast development of CV and NLP technology, generative text-to-image model has gained great popularity among the public for their powerful capability to generate high-quality images. They enable users to craft natural language prompts, adjust model parameters, and try out more seeds to obtain the desired output. However, due to the complexity and ambiguity of natural language, it is challenging for users to develop effective prompts to get the desired output. Moreover, prompts can result in distinct images based on different model parameters. Therefore, it is difficult to evaluate the quality of prompts with limited attempts on model parameter values. Some prior work has summarized a taxonomy of prompt modifiers for text-to-image creation. However, these guidelines could be too general to satisfy personalized creation needs. Some other work propose automatic techniques for prompt improvements. Nevertheless, the image creation process greatly depends on human subjective judgment, requiring human-in-the-loop to refine the generation. To address the challenges, we propose PromptMagician. It helps users efficiently explore and evaluate the model-generated images, and iteratively refine the input prompts and model parameters. The system pipeline is shown as follows. First, it allows users to configure model inputs, including prompts and the range of guidance scale. Then, the system employs the Stable Diffusion model to generate a set of image results with different model parameter values. Meanwhile, the system recommends similar image results and relevant prompt keywords to help users refine the prompts. Finally, the images and the prompt keywords are visualized in the user interface to support exploration. Next, I will introduce the prompt recommendation model, which consists of 5 major steps. The first step is to retrieve similar images for the user prompt. Here we use DiffusionDB, a large-scale dataset of Stable Diffusion works for image retrieval, and employs the CLIP model to encode the dataset images and the user's prompts, respectively. Then, we use cosine similarity to find the most relevant image results. The second step is image embedding. We continue to use encoding vectors from the CLIP model and project them into 2D space by t-SNE to preserve the semantic similarity of the images. Then, we perform hierarchical clustering on the images according to their locations, so that the images with similar content and style are gradually aggregated into clusters. Next, we identify important prompt keywords for these image clusters. For example, for the current image cluster, watercolor and Kirgi Purple are important keywords because they have a stronger impact on the image style and content. To identify such prompt keywords, we design cluster-level TF-IDF to measure the importance of prompt keywords for the given image cluster. Moreover, we introduce Ngram to identify important multi-word phrases and eliminate the stop keywords to improve the effectiveness. Finally, since the prompt keywords may be identified in multiple clusters with different importance, we match the prompt keyword to the cluster with highest importance, and this correspondence can better show what kind of images the keyword can produce. The user interface of PromptMagician consists of 4 views, including the model input view, model browser view, image evaluation view, and the local exploration view. As the main window of user exploration, image browser view visualizes the images according to their semantic similarity. The recommended prompt keywords are placed near the image clusters. To mitigate the visual clutter of large image collection, we introduce multi-level visualization so that the images in the clusters are gradually visualized as the view is zoomed in. All images and keywords support user interaction for detailed exploration. Image evaluation view enables users to evaluate image results from multiple aspects, including objective and subjective aspects. Users can evaluate images by specifying a pair of opposing keywords, such as colorful and gray, or real and abstract. Local exploration view helps users to deeper explore the selected image subset. Users can view details such as high-resolution images and the prompt sentence. Prompt Keywords panel lists the important prompt keywords and their usage relationship with the images. Users can also check the content and precision of the prompt keywords in the original sentence. Finally, the guidance scale panel visualizes the value distribution of the image subset, providing a reference for users to adjust the parameter range. We demonstrate the system workflow through a usage scenario. In this scenario, the user desires to create an anime-style work featuring a cat. She provides the initial prompt, a cat on a table under a tree in the style of Japanese anime in model input view. Being unfamiliar with the model parameters, she sets the guidance scale range from 5 to 30 and requires the system to generate 50 images at a time. Following a brief waiting period, the system produces a collection of images in the image browser view. After browsing through the results generated by the model, the user finds that these results do not align with her expectations. To refine her prompt toward the desired style, the user explores similar images for inspiration. Given the considerable number of search results, the user specifies artistic criteria based on the keyword pair of cute and ugly to select images. In response, the system visualizes the distribution of all images ratings on this criteria. The user brushes to select the cutest images. Subsequently, she identifies some images characterized by a tutorial style. She navigates the view to explore the images in this style and finds some related prompt keywords surrounding the images. As the user prefers this style, she selects some of the images for further exploration. The details of the selected images are listed in the local exploration view. After a brief review of these results, the user proceeds to examine the suggested prompt keywords in the prompt keyword panel. She finds that the top recommended prompt keywords, Hayao Miyazaki, Studio Ghibli, and Totoro, are strongly associated with the style and are frequently used by the selected images. However, the Totoro has a more substantial impact on the subject of the images, which is not the user expect. Therefore, the user chooses the first two keywords to refine her original prompt. Additionally, the user specifies a narrow range of guidance scales, referencing the selected images. As a result, the system generates a collection of images in the style of the Totoro movies. Finally, the user selects some of preferred images as the outcome of this creation process. To evaluate the system, we conducted a user study and recruited 12 ordinary users from a local university. Participants were required to complete open-ended creation tasks using our system and two baselines. The creation task consists of 3 major steps, including selecting a theme, writing an initial prompt, and iteratively improving the prompt using the systems. Based on user feedback, our system, including the prompt recommendation model and the visual interface, is effective in helping users explore prompt keywords and improve generation results. Besides, the system also achieves high usability. In addition, we also collected user feedback on the creation experience. Overall, our system provides better creation support because it facilitates the selection, analysis, and understanding of keywords. To further inspire feature work, we interviewed 5 experts from the Midjourney creator community and summarized a set of design implications. Due to the time constraints, I will introduce the second point here, and the others can be found in our paper. In the interviews, experts mentioned that overusing keywords could lead to semantic contamination. For example, using multiple color keywords could result in color confusion. Experts believe that our system can help users select effective, efficient prompt keywords rather than copying and pasting the entire prompt text. Therefore, experts also called for feature work to better balance between the brevity and the effectiveness of the prompts to avoid semantic contamination. Regarding generalizability, besides text-to-image creation, our system can be generalized to other scenarios. For example, in content moderation, our system can help examine and mitigate the potential misuse of text-to-image models. Or in model analysis, it can help model developers better evaluate model capability boundaries. In the future, we will continue to improve our system, including by supporting more model parameters and introducing deep learning models for human-in-the-loop prompt engineering, especially multimodal models like GPT-4. It can automatically improve user prompts based on images of their interests. That is all. Thank you.